Welcome to the Explainer. So today we're going to talk about something you probably look at every single day, the lines on a digital map. We totally trust them, right? But it turns out there's this hidden, really fascinating world of complexity behind where those lines, for things like parking spots, even come from. I mean, think about it. You pull up an app, you're looking for parking, you just assume that app has a direct line to some giant database with every single painted line on every street. It just seems obvious. Well, here's the twist. For the most part, you'd be wrong. That super specific data, I'm talking the exact coordinates of a curb or parking space, it just doesn't exist in the big mapping APIs that developers rely on every day. And yeah, you'd think the huge players like Google would have this all figured out. But look at this. Neither the main Google Maps API nor the more specialized Roads API can actually generate these street line segments. This leaves a massive data gap for anyone trying to build an app that really needs that info. And this isn't just some, fun trivia. It's a real-world headache for software developers. They've got these amazing ideas for apps, but they get stopped dead in their tracks because a piece of data they thought would be there just isn't. So what was the workaround? Well, for a long time, the only real option was to download these enormous city-sized data sets from projects like OpenStreetMap. And sure, it's possible, but it's clunky, it's slow, and it's a huge pain. Developers were desperate for a better way, and they need it for so many cool things. Imagine an app that guides you to a specific open parking spot at the curb, or a city planner who wants to simulate how new bike lanes would affect traffic. Even those augmented reality apps that paint directions onto the real world, they all need to know exactly where the curb is. All these great ideas hinge on this missing data. And that brings us to the hero of our story today, a really clever project called streetApi. It's this brilliant solution that doesn't go out and find new data. Instead, it just builds what it needs from what's already there. So what is it? Well, it's this incredibly clever method that takes the one piece of data Google's API does give you, the center line of a road, and then it just uses math to figure out where the curves and parking spots should be. And this is the part that is so cool. streetApi isn't a data finding tool, it's a data creation tool. It is just a perfect example of how some smart math can solve a really practical, real-world problem. Okay, so let's get into the weeds a bit, because this is where the magic happens. How in the world does a piece of code look at the middle of a street and just draw a parking spot next to it? Well, it's not magic at all. It's just math. On a high level, the whole logic is kind of like a recipe. First, you pinpoint the center of the road. Easy enough. Next, you figure out the street's angle, which way it's pointing. Once you have that, you can use math to build a perfectly aligned rectangle on one side, and then you just mirror it to get the other side. Simple, right? Now, that first key ingredient is something called theta. It's just a fancy math term for the street's angle relative to north. And this is absolutely critical. If you get this angle wrong, your parking spot is going to be crooked and totally useless. Everything else the algorithm does depends on getting this rotation perfect. Okay, next up, there's another problem. Let's say your parking spot is 2.5 meters wide in the real world, but your map doesn't think in meters. It thinks in degrees of latitude and longitude. So you need to translate that. That's what this normalization vector G does. Just think of it like a scale converter. It makes sure your 2.5 meters is drawn to the right size on the map. And finally, the algorithm pulls it all together using these two tools called matrices. It's like a toolkit. Matrix M is the basic blueprint for a standard rectangle, and Matrix T is the tool that takes that blueprint and spins it around so it perfectly matches the street's angle, our good friend, theta. So we have the logic, we have the math. Now let's see how this all turns a simple request into something an app can actually use, something visual and real. The whole thing is really a transformation. A developer starts with a super simple input, literally just the four corners of a box on a map. And what they get back from streetApi is this incredibly detailed output, a file that lays out the precise coordinates for every single parking spot it generated. So this is what the developer provides. It's so simple. They just say, hey, look inside this box on the map by giving the coordinates for the top left and bottom right corners. That's it. That's the entire request. And what they get back is this beautiful structured data. For each and every parking spot, it gives them the exact latitude and longitude for all four corners. A, B, C, and D. It's literally a digital blueprint that tells a program exactly where to draw each and every rectangle. So, at the end of the day, this output isn't just a bunch of numbers. It's an instruction set. All that complex math we just talked about, the angles, the vectors, the matrices, it all gets boiled down to one simple, powerful command that finally solves the developer's problem. Draw a box here.
And this is what it all leads to. That raw code gets turned into visual lines on your map. Parking spots just appear, and they're perfectly aligned with the road. Curbside data is literally generated out of thin air. And a problem that stumped so many smart people is solved not with more data, but with pure ingenuity.
And that kind of leaves us with a really fascinating question to chew on. streetApi created something totally new and valuable from nothing but logic and the tools that were already there. It makes you wonder, what other invisible data, what other hidden solutions are just waiting for us to build them from the technology we already use every single day?